Alright guys, so welcome back to the second part of the assignment on clustering. So as you know, in the last video we had covered k-means clustering, and now in this video we will be doing hierarchical clustering. And then in the end we will wrap up the entire assignment. So let's start where we left the previous assignment, that is question 6. Now if you see, question 6 has got two parts, and it says perform a complete linked hierarchical clustering to see if we can gain any more insight. The second part says, cut the tree and plot dendrogram. So in this question, instead of k-means clustering, we will perform hierarchical clustering. So for doing this, we will have to use hclust function. Now to use hclust, we will need the distance matrix. So what is the distance matrix? Distance matrix is a table that shows the distance between pairs of objects. Recall that we use Euclidean distance, Manhattan distance, etc. This distance matrix is nothing but the distance between the pair of observations. So we can mention the method as Euclidean, Ward, Manhattan, etc. Otherwise, it will use Euclidean by default. So this distance matrix is required as the first argument for the hclust function. Hence, we will convert our data into distance matrix and then only we will use it. So we will use dist function and give our data as the argument. It will convert our data into distance matrix, and this will be our first argument for the hclust function. Then in the second argument, we will mention method is equal to complete. That means we are using complete linkage. We can run this and store it in the variable h.clust. Then we can use the summary function and see the summary output. Now I have explained this output in the explanation given below, but before that let's plot the dendrogram. So we will use the plot function and then mention as.dendrogram and give the output of hclust as the first argument and run it. This will give us the dendrogram as shown here. However, as you can see, there is nothing readable in the dendrogram. So let's see what is given in the explanation here. Now the first 2 points are talking about the distance matrix that we have already discussed. Then the third point says the dendrogram is not interactive. That also can be observed from the plot itself. Then we'll move to fourth point, which says usually we are more interested in dendrogram. Still few terms of the output summary of hclust is explained below. So let's see what these terms are. First is merge. The merge is a n-1 by 2 matrix that shows at each step which two items are combined. These are either individual observations with a negative sign or clusters created at a previous stage with the row number. So I have explained this below with the help of an example. But before that, let's understand the other terms of the summary output. Then we have height, which is the distance between two clusters. Then we have order. This is used for plotting cluster plot. It is a vector of permutations of original observation such that a cluster plot with matrix merge will not have crossing of the branches. Then we have labels. It is the label of leaves, which is by default row names, and if it is set false, then it will be null. Then few other terms are mentioned here, but they are not that important. We can skip them and move on. Now before I explain the merge, the last point says we can cut the dendrogram at 4 using the above script plot that we got from k-means and consider it as base, or we can cut it based on our visual inspection of the dendrogram. Now let's see what is merge. So to see merge, we can simply subset it using h.clust with a $sign, and we will only see the first 5 observations. Now let's read what is the explanation given here. It says the first 4 steps consist of 2 individual observations being joined to form an initial cluster, indicated by the negative sign for each ID. And then at step 5, observation 257, that is shown by minus 257, is joined with the cluster established in step 1, that has the observation 230 and 268. So this is how merging happens, and that is what we get from the merge output. However, it is not important for us to know all these things at this stage. Still, I have given an explanation to make you acquainted with these things. Otherwise, this is not required at this stage. Now we will move to question 6b. It says cut the tree and plot the clusters. So we can use cut tree function here. The first argument would be h.clust and the second argument would be k is equal to 4. Now recall, in our previous video of k-means clustering, we found out from the scree plot that a 4 cluster model is the optimal one. So that is the reason we are using k is equal to 4 here as well. We can run this and store it in the variable cut. Now there is an explanation given here. So let's read the explanation. It says cut tree returns the clusters that each observation is assigned to. In our case, each observation is assigned to one of the 4 clusters. So now we can simply use it and subset the values of our data frame based on the cluster that they are assigned to. So we will make our plot by subsetting the data frame. So first we will use the plot function and plot our data as shown here. Then we add clusters by using the points function. So the first argument will be our data, which we will subset using the output of cut tree, which is stored in cut. So we will mention cut is equal to 1 for our first cluster, cut is equal to 2 for second, 3 for third, and 4 for fourth. And obviously we will include all the 5 columns. Then we will mention PCH. Then we will mention the color. Again we will mention the legends using the legend function as we did above, so I am not going to explain it again. After that we will run this, and here you can see the clusters are printed. Now if you compare it with the K4 means clustering, you will notice that they are quite different. However, it does not mean that earlier was wrong or this one is wrong. It is just that we have performed a very basic clustering. Now we can try different parameters and change them to improve our results. My intent was to demonstrate the process of k-means and hierarchical clustering. However, in general, k-means is a more robust approach and it is a popular method which is being widely used. But I hope you have got a good idea about both the methods now. Now I have given a link below. You can go on this link and practice more clustering. This will help you broaden your knowledge and understanding of clustering. So I suggest you do try this at home. Now with this we have completed both the assignments. So let's quickly revise what we have learned so far. We started with k-means clustering in the first assignment. Then we have learned some complicated loops in it and also plotted the clusters. Then we have made the predictions and included the predicted clusters on the plot. We have also seen how we can select the best k-means cluster. And then in this assignment we have learned about hierarchical clustering, we have cut the tree and then plotted the clusters. This was a huge topic, and in case if you are missing on some of the concepts, then I would suggest that just watch the video again, because I have explained each and every concept right from the beginning. So just watch the video again to get more clarity about it. You may also Google it and learn more about clustering. Now I will see you in the next video of advanced modeling technique. Until next time, have a good day.